Hi everyone and welcome to my new video in which I will continue my OSCP technical guide. Now at this point in the series we have almost reached the end. In particular in this video I will cover the client-side attacks chapter, and in the next two videos I will cover Active Directory and report writing. So in this video we focus on client-side attacks. I will read the blog post and then I will showcase two specific examples of client-side attacks. One against a web server through an XSS and another with a Windows setup, spawning a reverse shell with PowerShell. As always, if you have any feedback, please leave it in the comment, and that's it. I hope you enjoy the video. And so we can put full screen the blog post and we can start reading. Another important technique that the course teaches you is about client-side attacks. These form a really important class of attacks, as they represent an extremely useful and effective attack surface when trying to get within a corporate network. Now this is really useful because even though OSCP itself is not much about client-side attacks, they are still mentioned and you can still find them in the challenge labs and sometimes also in the exam sets. These kind of attacks are really useful because most of the time, for example, when a company network is breached, when an internal company is breached, it is typically done initially through a client-side attack. Someone is phished through a client-side attack. Now, in terms of the actual attacks and the techniques you use for doing these kind of attacks, we find the following ones: cross-site scripting, Microsoft Word macros, and Windows library files. Now, the idea of client-side attacks is that instead of attacking the server, which is what we typically think of, and in the past videos of this series we've always covered server-side vulnerabilities, server-side attacks, client-side attacks have a different goal in mind. They don't want to compromise the server. They want to compromise other clients. For example, cross-site scripting. The first attack, the XSS, allows us to execute malicious JavaScript within the context of the victim client. So what does it mean? It means that every one of us uses the browser to browse through various websites, and typically when we log in into a website, we authenticate, and the website generates a cookie, sort of like an information that we are authenticated to the website. As long as we have that cookie, we do not need to every time use our information to log in. We can just use the cookie. Now, JavaScript allows us sometimes in certain scenarios to extract those cookies to do various things. The problem arises when our browser executes malicious JavaScript, which means JavaScript that was not intended to be executed by us, by the developers, but it was injected by a malicious attacker. In those cases, it could be dangerous. Now, this does not translate directly into code execution in the victim machine, since typically there are many abstraction layers with solid protection mechanism between the JavaScript virtual machine that runs in the browser and the underlying operating system. And this means that even if an attacker is able to execute JavaScript within the context of our browser, he cannot get directly code execution into our operating system, because between the JavaScript virtual machine that runs in the browser, which is where the attacker has execution, and the operating system, there are a lot of layers of abstractions. It's protected. It's meant to be a sandbox area of code. Having said that, XSS attacks can still be useful to target specific web application, and this XSS stands for cross-site scripting, as we said. So even though they do not directly translate into code execution, they can still be dangerous. And at the end of the video, I will showcase an example of such an attack. We can, for example, try to steal administrator cookies, or perform actions using administrator privileges, such as creating a new privilege account. And in the scenario I will show at the end of the video, we will do exactly that. We will steal the administrator cookie through an XSS. Now, the other two types of attacks instead have a bigger impact, because there is a higher chance of actually executing code within the victim machine. And here I'm talking about Microsoft Word macros and Windows library files. Both of these attacks exploit Windows software and are therefore limited to the Windows environment. I suggest you to learn how to carry both of these attacks, also considering that the importance of these techniques goes beyond the OSCP certification. And the idea here is that With Microsoft Word macros, essentially, we embed malicious code within a macro in like a Microsoft Word document, so like in the Microsoft Office suite. And when a user opens that and enables the macros, is able to, like the attacker is able to execute code within the context of the victim software, while Windows library files allows an attacker to hide a malicious directory within the user File Explorer. So the user thinks he's going into a normal directory in his own machine, but actually is going into a remote directory controlled by the attacker. And then if he clicks on some directories there, on some files there, he might trigger some PowerShell code. So this is sort of the idea. And as I said, I suggest you should learn both of these techniques. Now, how probable it is that you will have to do one such technique in an OSCP exam? I don't think it's very likely, but you should still cover this area because it's important, and sometimes the attack vector to get inside the machine is exactly a client-side attack, so you should have this technique mastered and under your control. And regardless of OSCP, you should try to learn these kind of attacks for two reasons. One is for defense, for knowing better how a malicious actor might try to phish you through a client-side attack, and two is for offense. When doing red teaming, for example, in certain times when the scope allows you to do that, you can try to do this sort of attack to get inside the company's network. So this sometimes is a technique that is allowed during red teaming. So to finish off, remember that when it comes to this sort of attacks, they are usually not completely automated, meaning that we need a victim to perform certain actions, such as enabling macros within a Word document or clicking an attachment within a received email. This means that we must pay careful attention to the setup of the attack. In these situations, even small details, such as the name of the file extension or the graphical icon that appears in the File Explorer of Windows, can make a huge difference between a correct exploitation and a failed one. And this is a key point to remember, especially when you have to do this sort of attacks during the exam. Sometimes these attacks actually do not have a real victim. For example, in the OSCP lab or in the challenge labs. Sometimes in the challenge lab, you have to do these sort of attacks, but it's not like there is an actual person there clicking on things. So this setup is automated, which means that you have, like, for example, a script which clicks on each file with this sort of extension, like HTML or JS or HTML. And so you have to like try different extensions, you have to try different names and things like that. And then when it comes to real attacks of the sort, then at that point comes the psychological factor of the person you are sending the email to, for example, or you are trying to phish in general. And all of this is like, it's really hard to automate perfectly. There's no perfect rule for this sort of attacks. You just have to start to build some intuition around it. Now, in my cheat sheet, the one I've also uploaded on GitHub, and you can find the link in the description, there is a section under exploitation in client side, which showcases a typical client side attack you can do. It's like an email phishing attack. So the idea is, first we enable a WebApp server. This is gonna be our malicious WebApp server from which we serve our malicious files. And here are all the things you need to set it up. So you need pip, you install the dependencies, the WSGI DAV and chroot, and then you start this DAV with authentication anonymous. So everyone can connect, the port is 80 and you listen on every interface. And then here you give the root name of the directory you want to expose through WebApp. So the idea of the attack is this: you start this server and then you send an email to the client you want to attack, to the person you want to phish. Now in this email you will have an attachment which is going to be a config.library.ms. This file will be interpreted in such a way that the final client, the one we want to phish, is going to see a directory. So instead of the attachment, it's going to see a directory. But when he clicks on the directory, he's actually connecting into our WebApp server. So here is the setup for this config.library, and the only thing you really need to change is this IP address, because this IP address is going to be the address that the user will connect to when he clicks on the directory. And this folder type here, this code, is the directory icon. So like we are changing the icon to make sure that the user does not understand that he's actually connecting to a remote file system. For him, it's just going to be like a directory, it connects to it, and it's going to be like a local directory, like a file explorer directory. Now, within our WebDAV share, then, we're going to have a malicious link file, for example, PowerShell.link, and in this file, we can essentially put our PowerShell code. So it's going to click on the link. Of course, maybe we will not call it PowerShell, we should call it like with a different name, but essentially it's going to be a link file, and in this file we can put such payload, and this payload is used to download a reverse shell in PowerShell from our client point. Here we're using a different port, we're not using port 80 because this payload can be hosted in a different server, like a different web server. Maybe we can send even a malicious body, and then we can send the email with like swags with SMTP. So we say, this is the address you want to send this is the from you want to send it, this is the attachment, which is the config library, then the server, the body, the header, and whatever, like all the stuff for the email. So this is how typically these sort of attacks are performed. Now, I will not show this in full detail, I will just show the final act, the user clicking on the link and spawning a reverse shell. So the setup is as follows. Here on the left, I have a Windows virtual machine. On the right, I'm gonna start a netcat listener for a reverse shell, and down below, I'm gonna start a Python server, which will serve the reverse shell payload. Now, this link was placed before by the phishing attempt. We'll just see what happens when the user clicks on it. If we make the user click on it, what's gonna happen is as follows. We click on it, the script calls the web server to download the reverse shell payload, and the reverse shell payload is executed, and here on top we have a shell, and we have this shell as the user administrator because we click on it as the administrator. Of course, here like the shell still pops up. We are not like doing a full phishing attack bulletproof or something like that. It's just to show that typically this is how it's done. Of course, the problem is in making the user click on this file. Now, if we open this file and we just see properties, we see that the target of this file essentially it's as follows. So we just take this target value. Let's see if we are able to copy it over the machine. So the target is as follows. We call PowerShell with this payload, with this C to execute, and the payload is this IX to download the string, and then we execute. So we execute the payload of this reverse shell, this invoke PowerShell TCP. And in this invoke PowerShell TCP, of course, what do we have? We have the payload for the reverse shell in PowerShell. So this is the general idea of the attack. Now, in the future, I will talk more about this sort of attack, but this was a small preview into how these sort of attacks work. And now the attacker has a full shell on the system, and he can, for example, we go into users administrator, and then we go into desktop, and then we create make dir test. And then we have a new directory which has created the malicious users from the PowerShell. And of course we can remove it. And things like that. We have compromised the system by letting the user click on this kind of thing. Now, the final scenario that I want to show is instead with the XSS, and in particular with the stored XSS. I will showcase this using the DEM vulnerable web application, which is an application written in PHP made to be vulnerable. So it's used as a teaching tool to showcase the most basic web vulnerabilities. Now, if you're interested in more videos on this series, please let me know, because recently in my Italian channel I've created a series on it, so I can also make it in English if you want, in which I explain all the various vulnerabilities. In this video, I will go quickly just over a particular cross-site scripting, which is of type stored, because there are many different types of XSS. So what's the idea of this XSS stored? Well, the idea is that anytime we have a web application which allows us to write to a database, and the content present in this database is used to create the final HTML page, such as this case. So like in this application, we have like a sort of guestbook, and we can sign it. We can say Leonardo, and the message is please sub. We can sign our guestbook so that every time we go into that page, we have this message in the HTML. And here I'm using burp to analyze the request. Essentially, to sign our name, we do a post request on the endpoint /vulnerabilities/xss_s. Here is the version of HTTP. Here is the host name, which I use evil, and I use this in order to proxy the request from Chromium to Burp Suite. And then here are the parameters of the request: txt name, txt message, and btn sign. So this btn sign is the action we want to take. So we want to sign the guestbook. This is our name, and this is our please sub. We can send this request to repeater to send it again, and we can change the name to lt. We send it again, and when we refresh it, we have a new message. And we can also clear the guestbook as follows, so that we have cleared all the messages. Now, if we check the source code of this page, which this application allows us to do because, once again, it is made for teaching purposes, we do view source, and we see the PHP code that is working beneath it all. So this PHP checks if the parameter btn sign is set in the post request. We extract the input from the post request with the parameters mtx message and txt name, and we put them into two variables, message and name. Then we sanitize the message for SQL injections to avoid SQL injection, and we sanitize the name to avoid SQL injections. However, we do not sanitize with respect to XSS. After this sanitization has taken place, we update the database. So in particular, we do an insert into the guestbook table with the values message and name. Now, this sort of things does not take into account XSS attacks, which means that we can use such payload. For example, we can say lt as the name, and as the method we can do a script tag, which is used to execute JavaScript, and then an alert one. Now, if we do such thing, and we sign the guestbook, notice that when we get the page back, we execute some JavaScript. So we do evil says 1, so we have executed that alert statement. Now, why is this the case? Well, this is the case because this is the post which contains the malicious payload, and if we check the response from the server here, and we check the HTML that the server gave us, here at some point, what do we see? We see this tag script. So within the HTML returned to us by the server, we see this malicious script here, and so the browser, which is like unknown to all of this exploitation attempt, simply reads the HTML, sees the script tag, and simply executes it. Now, being able to execute an alert statement is still not a critical vulnerability, because other than this alert box, we have not proved that we can access critical information. And also notice that the threat model is that the malicious user does this post request, and then every other user, when accesses this particular page, when they access this particular page, they get executed the malicious JavaScript that was put by the malicious actor, by the attacker. Now, in this case, the actual idea to make this exploitable is as follows. We're gonna use the fact that through JavaScript, sometimes we can access the cookie of the user who's logged in the application with the variable document.cookie. So this is the JavaScript console. We access document.cookie and see that we have access to the actual PHP SSID cookie of this application. Now, the payload then has to be changed in the following way. We have to put in the payload this JavaScript code. This code performs an HTTP request, but this time the request must be performed to the malicious attacker. So we can say, for example, 127.0.0.1 port 1338, because currently the application is running in localhost, so the malicious attacker is also running on localhost. But here we can put any public IP, so that the most important thing is that the browser of the victim must be able to access this IP address. And then here in the URL of the request, we also put this thing, which is very important. So we put dash, then dollar, and then document.cookie. This is the string interpolation in JavaScript, and it allows us essentially to leak the cookie in the URL request we perform to the attacker. Now we wrap everything in the script tag to put it into the XSS payload. So we close the script tag, and now, of course, before exploiting this, we need to start the server. So we need to do Python, we start a server, listening on port 1338. 1338, so let's see, we have LT. Actually, we can clear the guestbook. We have LT. We have this new malicious payload. Okay, apparently we cannot paste everything, so we must do through the intercept. So let's activate the intercept. Let's sign the guestbook. And then here we change the message with our payload and we encode everything. So we do URL, encode the key characters. Then we send it as request, and notice what happened beneath here. We got the cookie of the user logged in, which was our user, of course. But we can think of that any users who gets into the page, here we put the intercept off. Now at this point, once we put the malicious payload on the database server, every time any user goes into the site and clicks on XSS stored, we get his cookie. So this is another scenario which I wanted to showcase that shows how dangerous these client-side attacks can be. And this is, of course, a small example. If you want more examples regarding web exploitation, I can do a small series on this application to showcase like various vulnerabilities, CSRF, common injection, file inclusion, and things of the sort. And so this concludes this video regarding client-side attacks. We've discussed them, so there are essentially three techniques that you should know. It's about using macros, it's about using Windows library files, and it's about using XSS. Although I have to say that for the OSCP exam in particular, I don't think you should learn much about XSS. I mean, I don't think there's gonna be many XSS because in the course they are barely touched. But the idea is that they are still very, very important to know and learn. For the OSCP exam, I suggest you learn the other two client-side attacks, which have to do with Windows library files and macros. But that's it. I mean, the general idea is that client-side attacks are not too important for the OSCP exam. They could happen, so you must study them, but in general they are really important techniques that you need to learn in order to do like web-based penetration test, also mobile penetration test, and in general even during red teaming you might use one such attack to get inside the corporate network. Now we are reaching the end of our guide. In the next video we will talk about Active Directory. I hope the video is enjoyable. If you have any feedback, please let me know, and to the next video.